Hey kids, Mrs. Lowe here. By request, I'm going to do some factoring problems. The first one is GCF only, though this is the first step that you always go through when you're factoring, looking for a common factor, in fact, the greatest common factor. There's a number of ways to find the greatest common factor. A prime factor tree is generally the best, but a lot of times you can just look at the terms and determine what's the largest number that divides into all three of those, and that's 2. What's the largest number of x that they share? They share up to x squared. And what's the largest number of y's that they share? They only share 1. And there's your GCF. I'm going to place that on the outside of the parentheses. You will have 3 terms left over because you have 3 terms to start with. So you ask yourself, 2 times what gives me 12, and that would be 6. And then do the same thing for the variables. X squared times what gives you x to the 4th, that's x squared. Y times what gives you y to the 3rd, and that's y squared. And you repeat the process down the line, and you check by multiplying back out. So I did that pretty quickly, but I'll just show you that it works. 2x squared y times negative 3xy cubed does give me negative 6x cubed y to the 4th because you add the exponents of the variables. And 2x squared y times 1 does give me 2x squared y. So there it is in factored form. All right, moving on to the next type of problem. It is factoring by decomposition. Well, first thing you always do is look for a GCF, and I do see that this term has a GCF, so I'm going to factor it out. Don't lose that 2. You're going to need it all the way down. Now I'm going to identify A, B, and C of my quadratic, which is in standard form. A is 1, the number in front of the x squared. B is negative 2, the number in front of the x. And C is the constant, the number by itself. The product is A times C, so negative 35, and the sum is B, which is negative 2. So I'm thinking of 2 numbers that multiply together give you negative 35, but add give you negative 2. Negative 7 and 5 are the 2 numbers. So the middle term decomposes into negative 7x plus 5x, hence the process is called decomposition. I bring down the first term and the last term and bring down my parentheses and my 2. Now I have 4 terms. I'm going to factor by grouping. GCF for the first 2 is x, left with x minus 7. GCF the second 2 is a positive 5 because that sign is positive. Bring that out. You're left with x minus 7. Notice that these are the same, so that is a common factor. And when you factor that out, you're left with x plus 5. Don't forget you have a 2 out here. It has to be outside its own set of parentheses, and then the 2 can come down to here. So there is your final factorization. So we did GCF, we decomposed, factored by grouping. And the last one is a difference of squares. So when you factor a difference of squares, you use the formula a squared minus b squared, so you write it like that first, and then it factors to a plus b, a minus b. Remember, in order to factor it using a difference of squares formula, it must be a difference of squares. If you can't write it in this form, a squared minus b squared, it's not a difference of squares. If there is a plus sign, it's not a difference of squares. You would just try to factor out a GCF, and if you can't, you're prime. So first thing I'm going to do is I'm going to write this as something squared minus something squared. Hence show that it's a difference of squared. So this is 4x to the 4th. When you square that, you get 16x to the 8th. And this is 9. So my a is 4x squared and my b is 9. So now I can factor a plus b, a minus b. So I factored using a difference of squares. Now I need to see if either of these factors are a difference of squares, and this one is. So this one can also be factored using the formula. So this factors to 2x squared minus 3, 2x squared plus 3. Bring down the first factor and the equal sign. Neither of these, or none of these, are perfect squares or difference of squares, so you are done at this point. So we factored using the formula twice. We were able to write it in a squared minus b squared. I factored it to a plus b minus b. The second term factor can also factor to a squared minus b squared, so we can use the formula a plus b, a minus b. Hope this helps, and good luck on the test.